In Perth that a lot of us have used over many years, and he's come over here for the ASPAC meeting and also to talk to us today about commercial laboratory perspective on soil carbon and carbon measurement. Over to you, Jeff.
Thank you. Like our previous speaker, I too did a PhD in organic chemistry with no background in agriculture. It wasn't until I met a farmer's daughter who I showed a great interest in that I suddenly became very interested in agriculture. CSBP Soil Laboratory analyses approximately 150,000 soils every year. And taking into account that these soils come from every state and territory within Australia, and during our summer months when we're at our peak capacity, we're doing about 1,500 soil samples a day. I'm just going to talk about our experience with soil carbon purely from a laboratory point of view. And my talk will outline why is soil carbon important, which I don't really need to go through because our previous speaker covered that very well. From a lab's point of view, what are the commercial considerations? Taking a closer look at the Walkley black organic carbon test, and then we'll be looking at other options such as the total carbon or combustible carbon, NIR, MIR, and other soil carbon tests. As a previous speaker did say, that soil carbon can improve the soil structure, it increases water holding capacity, improves drainage, and this leads to better root development and nutrient retention. It's also important for the cycling of nutrients. So what are the sort of carbon tests that we do in our laboratory? Well, the major one we do is a Walkley black organic carbon, and then it'll be followed by total organic carbon, the Haynes modification. Then we do like loss on ignition, but that's mainly restricted these days to compost samples. We do total carbon. We use a LECO carbon nitrogen analyzer, and we do carbonate analysis. But before we look at any soil testing that we do in our laboratory, we have to consider a number of factors. The accuracy of the test. We have to ensure that the test that we are doing, that we can get the right result. And have we got the capabilities or the skill level in our laboratory to be able to do that test? Can we go out and recruit someone, or does it need some other special bit of equipment or something like that? So we have to ensure that that we can get the right result. We run a laboratory with over the summer months we have 60 staff. It is a bit of a factory. We get our 1,500 samples a day and we try and process them with that sort of capacity in mind. But to break the boredom up on a test, well, they're doing 1,500 Walkley blacks one day, or 1 week. The next week they could be doing 1,500 sulphurs, or they could be doing 1,500 pHs. So we rotate them around. So it's important that the people going on to doing organic carbons for the following week have the same skill level and can get the same results that the people were doing the test the previous week. And are there any hazards involved? Can that test be done safely? And how many of these tests can we do a day? Bearing in mind we're doing 1,500 samples a day. So, we're looking for a capability to be able to do that sort of number of samples. And what are the costs involved? Is there a big setup cost? Do we have to go out and buy some expensive bit of equipment? What about the consumables? The chemicals expensive? Are they easily available? And the gases. Some of the tests use a large amount of gases, so they're very expensive. Other maintenance issues. How many staff do we need to be able to do that test? We do 1,500 organic carbons with 3 staff in our usual 10-hour day. And I guess the final bit is, how much is the customer prepared to pay for that test? Will they be prepared to pay enough money that still leaves us with the margin to be able to, it's a commercial laboratory, to still come out ahead? It'll be very rarely that, it's only some researchers who ring us up in a very quiet time of the year. We will be willing to do certain tests at a loss purely because we've got our overheads and that, but in a busy time we have to be able to make some financial gain out of that test. So any test, as I've just said, that we are doing in our lab has to satisfy the demand for that test. And so we're working on our 1,500 samples a day, and Walkley Blacks, we certainly can do our 1,500 a day. Total organic carbons, we can do about 500. Again, these are our capacity limits. They're not, other labs may be able to do more or they do less. The loss on ignition, we do about 100 of those, but like labs in America can do several thousand loss on ignitions a day. Combustible carbon, it's up there as about 100. It's probably closer to about 200 a day we can do now because we've just bought a second machine. Again, the demand for doing total carbons is greatly increased over the last year or two, and to meet demand we've had to buy our second instrument. And then there's carbonates analysis. So as you can see, we're set up mainly to do the Walkley Black organic carbon. We've got the capacity to be able to do that. It's the one we can put through the most of. It is a relatively cheap test to do, and fortunately it requires the use of hazardous chemicals. During a year we use 1,000 litres of concentrated sulfuric acid and 100 kilos of dichromate. It is the test that my staff hate with a passion. And in America, in many parts of America, the use of the Walkley Black or the dichromate oxidation has been outlawed, and they've all moved over there to doing loss on ignition. So they're geared up and they can do 2,000 to 3,000 loss on ignitions in a day. When we talk about the hazards, we've as of next week we're taking delivery of a Janus liquid handling system. This is trying to make the test a lot safer to do. It actually is driven by 8 pistons there. We load a rack of samples. We have 8, it goes 8 by 12 hour racks. We have 8 tubes along here. So it will rapidly dispense in all the chemicals that's needed to do that test. So really all our staff will be required to do is to weigh out the source samples and really put them in and take them out. The issue has certainly highlighted itself over recent times. We've had a case of carpal tunnel syndrome. There's a lot of manual dispensing going on in the laboratory. So, we've tried to make this operation a lot more safer to do, and hopefully at the same time we will reduce any variability in that test. Now, when you've got a test that's not, your staff are not that keen to do, the results will tend to be a little bit more variable than a test that they feel very comfortable about doing. So this should certainly reduce some of the variabilities with the Walkley Black method. Going back to the organic carbons, there are some other issues with the Walkley Black method. It's we take a small sample size, 0.5 of a gram, to do our organic carbons. It's very easy to get segregation, a bit of organic matter out. You're weighing such a small amount of soil. Depending when you spoon out your soil, you can pick up a larger bit of organic matter, or you can miss it altogether, and that can lead to some variability in that test. If you go to a fine grind, that will certainly reduce a lot of the variation due to that sort of subsampling errors. When you hit soils that have got a higher organic matter, in our lab, our oxidising reagents run out at an organic carbon level of about 5%. So when it comes to 5%, we have to redo them all again, and we take half weights. So then, 0.5 of a gram is, is not a lot of sample. 0.25 of a gram is a lot less, and we find that, the higher pH, the higher organic carbon samples, you can get a lot more variability because you're taking such a small amount and then you're multiplying out by a bigger factor. So what are the alternatives? We find like the LECO total carbon, or total carbon by any sort of combustible processes, we find a bit more accurate. Unfortunately, it is extremely slow and it's extremely expensive. If we average out about 15 samples an hour, so if we were replacing our current throughput for the Walkley Black by the total carbon using a LECO, we'd have to buy something like about 7 LECO machines, which would come up to be about $420,000 based on recent costings. And not only that, we find that the cost, it's very, requires a lot of maintenance to maintain those instruments. You take a small sample size, again about 0.2 to 0.5 of a gram. Obviously you'll benefit from a fine grind to reduce the variability. We've just bought a second instrument, which is a True Mac to go with the LECO True Spec, and we're finding like a little bit of variation between one instrument and another. So I don't know that where that leaves you if it gets to the situation that the customer is getting paid for the amount of carbon you get in your sample. I mean, it's a nice test to do because it's simple. All you do is weigh out your soil, put it into the instrument, and 4 minutes later it prints out a result. But it is a very expensive test to do. Now I'll come to my controversial section here. MIR, NIR, there's growing interest in this technology. We've been involved with it for quite a few years now. It allows you to assess a number of parameters simultaneously, which are often difficult parameters to measure by traditional means. It uses mathematical algorithms for correlating between the spectral data and the tests you want to use it for, say in our case, the Walkley Black or total carbon. The key point is you have to develop a good, robust calibration before you can start analysing samples, and this can take quite some time. The calibrations can be area specific. If you develop your calibration based on soils from down the south or West Australia and try to use that calibration for analysing clays from Victoria, I think we'd find we'd be in all sorts of trouble. To get the throughput that we need, we have to go to multiple instruments, and there can be variability between one instrument and another. It's not a straightforward process to be able to transfer a calibration just from one instrument to another instrument, although it's not insurmountable. MIR uses, again, a small sample size. It does require a fine grind on that sample. NIR, which we don't really have any experience with, but I know it does take a much larger sample size. It really revolves around that the sample you want analysed has to be typical of the subset of samples that you used to generate the calibration and the quality of the analysis from which the traditional methods were used to establish that calibration. And this is our experience that if we run, and we come up with a reasonable calibration, we've got quite a few samples in there, But we still find that if we run a set of samples, we'll get good agreement on some and not so good agreement on other. I know some people are having, quite a lot of success with it, but I still have some reservations on it. If we have a look at the other test that we do, total organic carbon, this requires the extra external heating than the Walkley Black. Otherwise, it's very similar. It uses the same reagents, so you don't avoid, the hazards of using all the dichromate and all the sulfuric acid. Still takes a small sample size, so you can get subsampling errors there. Has a 5% maximum, and then we'd have to go and do it at lower sample size, and it would benefit from an extra fine grind. The longer analysis time due to the external or the extra heating reduces our capacity to gear up to a larger throughput in a day. Well, with loss on ignition, I visited some labs in America a couple of years back. These were the high throughput labs, and they're doing, one lab was doing 7,500 samples a day, and they were really putting through the loss on ignition. So it's very well automated, and I was sort of quite excited. I thought I had a way around the unpopular Walkley Black technique with my staff, and I was optimistic that we would be able to bring over loss on ignition over here. But I also was at the same meeting with George Raymond, who a lot of you would know, and he suggested that there's very poor correlation between the loss on ignition and the Walkley Black organic carbon. So before we invested a lot of money and time into it, we ran a set of samples through, and we certainly found that was indeed the case, and to this day we're sort of just sitting on doing loss on ignition on compost samples. Labile carbon, we haven't done a lot in this area. We've done a little bit with the permanganate oxidation method. On a small number of samples, we've got a good correlation between the results on that and the Walkley Black. And we can gear that up to be able to achieve sufficient samples through in a day. We've also looked at microbial biomass as a measure of labile carbon. We do it under contract for some customers in West Australia. It's a slow technique, but it's also extremely expensive. And carbonates, you measure carbonates by acidifying the soil and measuring the amount of CO2 given off. So to sum up, there's numerous tests out there for measuring carbon in soils. Walkley Black is the most common one, and there's many years of historical data on the Walkley Black. There's growing interest in total carbon. We've seen a rapid increase, particularly by researchers and by forestry, and there's also growing interest with MIR, NIR. But we're not sure that it's quite ready for that yet. That's me. Thank you.
Okay, thanks very much, Jeff. Some questions? One here and then one over there. Other way around, one there and then one here.
Jeff, can you mention a little bit about the Walkley Black correction factor? It was initially built into the technique when it was first developed with a 1.3 correction factor to account for the incomplete oxidation with the dichromate. When you include that in, we used to include that in, we'd often end up, or regularly end up with total organic carbon greater than total carbon by LECO, which really is a bit confusing to supply clients with those sort of results. Now in the Green Book, apparently they've removed this correction factor, so can you comment on that?
Well, we've never used the correction factor. The Walkley Black doesn't go to completion, generally they say about 85%. oxidation. And it's supposed to be reported as like organic carbon WB for the Walkley Black method. So we've always done it our way. There is variability in the organic carbon, total organic carbon. We've had the experience with total carbon for our new machines and getting some results with the total carbon being less than the total oxidisable carbon. But it's just a matter of we've gone to gone to a finer grind and redone it and checked our result. The new Lico we've got is a bigger sample size to the 0.5, so we're finding a little bit better result than that.
Do you then say that ring mill grinding would be the preferable way for all sample analysis for carbon?
I would say, but the throughput through sample prep is our bottleneck, and some researchers who specifically demand that we need to do total carbon done on a fine grind sample, but otherwise we're still using our less than 2 millimetre, purely because we're under huge pressures with our turnaround time, and we just could not get the samples through. We've got 3 grinders. If we then had to go through another fine grind, we just couldn't handle it.
Hi Jeff, my question is just wanted to know what your standard sample prep for your samples are when they go to the lab.
Just so that
Just the standard sample prep that goes through. So when you receive the sample at the lab, what actually happens to the sample?
Well, they're all dried first at 40 degrees on a fan-forced oven, so you blow the air over the top. Then they come out. We have our sample prep area. It goes on to, if it's a clay soil, goes through a jaw crusher, which it sits above a vibrating screen with holes in it, small holes in it, which siphons off the stubble, twigs, gravel, and what goes through to 2-to-1 cone splitter. Then, so it's only 1/3 of the sample goes through our grinding mill. Unless like researchers who send us minuscule samples, then it goes straight on top of a grinder because we can't split it, we can't do anything with it.
Okay, maybe this is the last question.
What about your compost samples, Jeff? We put ours right down through the ring mill. It's the only way we've found it works.
The compost, we take that more like a plant sample, so we grind that down fine.
Okay, thanks very much, Jeff.
Right.
So you'll see in the program now we've got some fine judgment for a structure. What we really wanted to do was